We write vector r as xi cap plus yj cap and zk cap. We can write vector f as fx I cap fy j cap plus fz k cap. So these are the Cartesian or rectangular coordinates. Now we are going to write torque in terms of Cartesian coordinates. So for this, let's consider a particle lying in xy plane. Okay? Consider a particle lying in xy plane. This is the x-axis, this is origin, and this is your y-axis. And we have a particle here at some point P. Okay? And the position vector of this particle from the origin, we can take the position vector, right? It's vector r. At point P, a particle is lying. The coordinates of the position of the particle, let the coordinates be x, y. So we have a particle, it lies here, okay? And we are applying force in some other direction, which is not in the direction of this position vector. Let's suppose this is the direction of force in which we are applying the force. ठीक है? तो यहाँ पे हम इस डायरेक्शन में फोर्स अप्लाई कर रहे हैं. अब क्या है? सो बिकॉज दिस इज द डायरेक्शन ऑफ फोर्स. अब ये पार्टिकल है हमारा यहाँ पे, ठीक है? पार्टिकल पी यहाँ पे है. अब इसका जो ओरिजिन से डिस्टेंस है वो ये है, तो इसको हम वेक्टर आर से डिनोट कर देते हैं. ठीक है? जो हम इस पे फोर्स अप्लाई कर रहे हैं वो किसी और डायरेक्शन में फोर्स अप्लाई कर रहे हैं. जैसे कोई पार्टिकल है उस पर हमने ऐसे फोर्स अप्लाई किया, तो ऑब्वियस है कि वो क्या होगा? रोटेट होगा. ठीक है? We are going to find work done in rotating this particle. ठीक है? तो अब जब इस पे आप फोर्स अप्लाई करोगे, so we can easily resolve this force into rectangular components. So horizontal component of this force is fx, and we can write vertical component of this force as fy. ठीक है? Any doubt? Because we have applied force in this direction, so particle will move from its position. तो हम क्या करते हैं? We always consider for small displacement, because here particle is rotating in the xy plane, so we can consider small angular displacement for the particle. So let the small angular displacement for the particle be d theta. Suppose after some time particle goes to point Q, it reaches point Q, and this is the angular displacement of the particle during this time interval. So in time interval dt, particle displaces by an angle d theta. ठीक है? अब at time t, particle was here at this point P. After time dt, after t plus dt, we can say particle goes to point Q. And suppose the position vector of this point from the origin, let the position vector be r plus vector dr. ठीक है? अब ये कैसे आया? क्योंकि हम स्मॉल एंगल ले रहे हैं, स्मॉल एंगल पे स्मॉल लीनियर डिस्प्लेसमेंट. So particle is moving from P to Q. We can also find you apply triangle law of vector addition here. ठीक है? We can apply triangle law of vector addition here. So vector OP plus vector PQ, है ना? अगर आप देखते हो तो vector OP plus vector PQ is vector OQ. So from here we can find this vector PQ. Vector PQ is vector dr. ठीक है? Clear? So we know that vector OP is vector r, right? And what is vector OQ? Vector OQ is vector r plus vector dr. So this implies vector PQ is, apply triangle law of vector addition here, this law. So vector PQ is vector OQ minus vector OP, है ना? So vector PQ is vector dr. यहाँ पे कोई डाउट है? क्लियर है? ठीक है? Now because we have rotated the particle by this small angle d theta, so small amount of work will be done. So small amount, write this, small amount of work done in rotating a particle from P to Q. ठीक है? Small amount of work will be done, and this small amount of work done, work is a scalar quantity, right? And it is a scalar product of two vectors, force and displacement. तो फोर्स अप्लाइड इज वेक्टर एफ डॉट स्केलर प्रोडक्ट है, स्मॉल डिस्प्लेसमेंट जो हुई है वो क्या है यहाँ पे, स्मॉल डिस्प्लेसमेंट वेक्टर डी आर। ठीक है, अब because we are considering only xy plane, we are not considering z axis, so we can write vector f as f x I cap will only take x and y component of f, not third component, z component will not take. ठीक है, so vector f is f x I cap plus f y j cap. Similarly we can write for this vector dr, what should I write here? dr क्या होगा, OP वेक्टर r है, OQ r प्लस dr है। अगर हम वेक्टर r p के कोऑर्डिनेट्स ले रहे हैं, p के कोऑर्डिनेट्स ले रहे हैं x y, so we can take the coordinates of q as x plus dx, y plus dy, right? How do we write vector OP? xi cap plus y j cap. And how do we write OQ? If the coordinates are given, then how do we write OQ? Position vector x plus dx I cap plus y plus dy j cap. Now because ये क्या है, position vectors है, we are dealing, we will consider displacement, है ना, हमें उसकी इनिशियल और फाइनल पोजीशन से मतलब नहीं है, हमें मतलब है कि उसकी पोजीशन में चेंज कितना आया, कितना वो डिस्प्लेस हुआ अपनी पोजीशन से, राइट? वो कंसर्न है हमारा कि डिस्प्लेसमेंट क्या है। तो डिस्प्लेसमेंट क्या है, डिस्प्लेसमेंट इज वेक्टर पी क्यू एंड वेक्टर पी क्यू इज वेक्टर ओ क्यू माइनस वेक्टर ओपी। नाउ सबट्रैक्ट दीज टू, व्हाट विल यू गेट, एक्स एक्स कैंसिल हो जाएगा, नाउ वी हैव दिस डी एक्स आई कैप प्लस डी वाई जे कैप। ये नहीं समझ आ रहा था, नहीं आ रहा था? So vector PQ is vector dr and we can write vector dr as dxi cap plus dyj cap. Okay, clear? Now because this small amount of work done is the scalar product of these two vectors, so whenever we have scalar product, है ना, how do we multiply vectors? डॉट प्रोडक्ट में कैसे मल्टीप्लाई करते हैं, i dot I is 1, I dot j is 0, j dot I is 0, है ना? तो I जो I वाले कंपोनेंट है उसको मल्टीप्लाई करोगे, बिकॉज I डॉट j तो 0 हो जाएगा, j डॉट I भी 0 हो जाएगा, राइट? सो वी कैन राइट एफ एक्स डी एक्स प्लस एफ वाई डी वाई। इसमें किसी को कोई डाउट है यहां तक? पक्का? ठीक है, अब लेट दिस एंगल with x axis be theta. Now the coordinates of this point P is x, y. ठीक है, so we can resolve this in polar coordinates also. देखो ये आपका है, look at this triangle, we have a right angle triangle, this is vector r, this angle is theta, coordinates of this point is given, it's xy and this is your origin 0 0. So we can write this vector r, this is x and this is y, right? This is how we do. अगर आपके कार्टेशियन कोऑर्डिनेट्स ही हैं, अगर आप नंबर लाइन में भी अगर उसमें कोऑर्डिनेट एक्सिस में अगर प्लॉट करते हो तो यू राइट लाइक दिस, एब्सिस एक्स एंड ऑर्डिनेट इज वाई। ठीक है, अब इसको अगर आर के टर्म्स में लिखेंगे देन वी कैन राइट एक्स एस आर कॉस थीटा एंड वाई एस आर साइन थीटा। लिख सकते हैं या नहीं लिख सकते हैं? लिख सकते हैं। ठीक है, तो dx क्या है, x is r cos theta, right? And y is r sin theta. अब हमें क्या चाहिए, we want dx and dy, so we need to differentiate these x and y. ठीक है, so let's differentiating x and y with respect to theta. ठीक है, so on differentiating x and y with respect to theta we get dx by d theta is equal to, r is a constant, and now differentiate cos theta with respect to theta, it's minus sin theta. So this implies dx is, बेटा बोलना पड़ता है क्लास में, आवाज आनी चाहिए। dx is minus r sine theta d theta. Now let's differentiate y with respect to theta. So y is r sine theta. So on differentiating y with respect to theta, because again r is constant, sin theta को theta के respect में differentiate करोगे तो क्या आएगा? Cos theta. So we can write dy as r cos theta d theta. ठीक है? Now because we know that work done is dw is fx dx plus fy dy. Okay, so let's substitute these values. For this dx we can write minus r sin theta d theta. For dy we can write r cos theta d theta. Okay, so in place of dx now we can write, see, first we have fx. In place of dx we can write minus r sin theta d theta. So minus r sin theta d theta plus fy. In place of dy we can write r cos theta d theta. ठीक है? Now what is this r sin theta? R sin theta is y. Look at this. R sin theta is y. So we can write fx minus y d theta plus fy. And this r cos theta is x. Okay, r cos theta is x, so we can write x d theta. Now this, take this d theta common. So in the bracket we can write x fy. Let's write this first because this is positive and then negative term. Minus y fx d theta. Write this. See, when we write work done in rectilinear motion or translatory motion, how do we write? We write work done as the product of force and displacement. है ना? We write work done as the product of force and displacement. So in translational motion, work done is vector f dot scalar product of f and dr. Small amount of work done is this. What if I want to write work done in rotational motion? Then we'll replace this force by torque and this linear displacement by angular displacement. So it's tau d theta, right? In rotational motion, f is replaced by tau torque and linear displacement is replaced by angular displacement. Okay, so this work done is, actually we can write this work done as tau d theta. Now compare these two. On comparing, you will get tau as x f y minus y f x. And close this in box. अब देखो, जब ये पार्टिकल P से Q में मूव हो रहा है तो यहाँ पे एंगुलर डिस्प्लेसमेंट भी है और लीनियर डिस्प्लेसमेंट भी है. यहाँ पे फोर्स भी है और टॉर्क भी है. इस पार्टिकल पे हम फोर्स किसी रैंडमली किसी डायरेक्शन में अप्लाई कर रहे हैं तो वो रोटेट हो रहा है. हम फोर्स अप्लाई कर रहे हैं तो लीनियर डिस्प्लेसमेंट भी हो रही है dr. अब बिकॉज वो रोटेट हो रहा है इसलिए एंगुलर डिस्प्लेसमेंट भी हो रही है d थीटा. अब बिकॉज वो रोटेट हो रहा है इसलिए यहाँ पे टॉर्क भी एक्ट हो रहा है. ठीक है, तो वर्क डन को आप लीनियर डिस्प्लेसमेंट की टर्म्स में भी लिख सकते हो एंड यू कैन ऑल्सो राइट वर्क डन इन टर्म्स ऑफ टॉर्क एंड डी थीटा. ठीक है, क्लियर? राइट द हेडिंग एक्सप्रेशन फॉर टॉर्क इन पोलर कोऑर्डिनेट्स. ठीक है, अभी हमने जो लास्ट जो डेरिवेशन किया है, ठीक है, उसमें हमने जो टॉर्क के कोऑर्डिनेट्स फाइंड किए हैं वो किसमें किया? कार्टेशियन कोऑर्डिनेट्स. ठीक है, हाउ डू वी राइट टॉर्क इन कार्टेशियन कोऑर्डिनेट्स? In Cartesian coordinates, we write torque as x f y minus y f x. Right? ये क्या है? This is the expression for torque in Cartesian coordinates. ठीक है? Now we have to write the expression for torque in polar coordinates. Again, consider the same situation. Draw a coordinate axis first. we have a particle at point P, okay, and we are applying force in a direction, in this direction we are applying force on the particle. So this is the position of the particle and this is the direction of force. Okay, the angle the position vector makes with x-axis is theta. This is your x-axis. And position of the particles, initial position of the particles were x, y. And we have applied force in a direction at an angle phi. Okay, so this is the direction of force. The force makes an angle phi with vector r. ठीक है, अब r और f के बीच में जो एंगल है वो क्या है, phi. पोजीशन वेक्टर जो x एक्सिस के साथ एंगल फॉर्म कर रहा है वो क्या है, थीटा. नाउ इसको क्या करेंगे हम, फोर्स का जो डायरेक्शन है ये, see this is the line of action of force and we take perpendicular distance from the line of action, right? So we'll extend this in the backward direction. ठीक है, so this is vector r hypotenuse जैसे एक्ट करेगा आपका, और we'll draw perpendicular here. ठीक है, so this is vector o, ये आपका r sin theta हो गया. No, this is not r sin theta, r sin phi, because this angle is phi, this angle is also phi. These are vertically opposite angles, है ना, ये vertically opposite angles हैं और ये वेक्टर r है. ठीक है, और ये परपेंडिकुलर है. तो ये आपका जो ये वाला साइड है pn क्या हो जाएगा, r cos phi, और on क्या हो जाएगा, r sin phi. और ये कौन सी लाइन है, लाइन ऑफ एक्शन ऑफ फोर्स, लाइन ऑफ एक्शन ऑफ force vector f. And what is this, this is the perpendicular distance from the line of action of force, है ना. We always multiply perpendicular distance from the line of action of force. केसेस में किया था ना, है ना, we always multiply perpendicular distance from the line of action of force. कुछ समझ आ रहा है, क्या किया हमने, we have considered a particle P at a point xy. ठीक है, position vector of the particle P is vector r. We have applied force in a direction this, in this direction. ठीक है, this is force F applied on this particle. अब क्या है, vector r ये है, F ये है, angle between vector r and vector F is phi, and the angle which r makes with x-axis is theta, and the angle which F makes with x-axis, let that angle be alpha. ऐसे, right? O, N and P. Look at this triangle PON. So this angle is phi. ये hypotenuse है, PN is base. Base is r cos phi. This is how we write. And a perpendicular is r sin phi. So ON is r sin phi. एक तो ये, ठीक है. So let's resolve this xy. Let's resolve this f. ठीक है, in rectangular components. So horizontal component of the force is this. It is represented by this direction. This is the horizontal direction. ठीक है, horizontal component of force. Angle is alpha. अब इससे vector f पे focus करो. Angle it makes with x-axis is alpha. So horizontal component of force is f cos alpha, and vertical component of force is f sin alpha. ठीक है, so this is the horizontal component of force. We can write f cos alpha here. And where is the vertical component? Vertical component of force यहां से भी ले सकते हो, इधर से. ठीक है, तो vertical component of force is this, f sin alpha. ठीक है, so we can write fx as f cos alpha, and Fy as F sine alpha. Similarly, we can write X and Y in terms of theta. Okay? Again, look at this triangle. This angle is theta. This is vector R. This angle is theta. Coordinates of this point, XY. We have XY here. Okay? So we can write X as R cos theta. And we can write Y as R sine theta. Okay? Now substitute these values here in this expression. Because torque is xfy minus yfx. So in place of x, we can write r cos theta. For fy, we can write f sine alpha minus, again, tell me. For y, we can write r sine theta. And for fx, we can write f cos alpha. Now we can take this rf outside, belongs to both, right? In the bracket, we can write cos theta sine alpha minus sine theta cos alpha. Sin A cos B minus cos A sin B. Sin A cos B minus cos A sin B is, बताओ maths. Sin A cos B minus cos A sin B. Sin A minus B. ठीक है? Sin A minus B. So sin, what is A? Alpha, and B is theta. So RF sin alpha minus theta. Sin alpha minus theta. What is alpha minus theta? See, look at this. How alpha, theta, and phi are related. Look at this triangle. How are they related? Alpha, this angle, and this angle. Alpha, theta, and phi. You can see that alpha is the exterior angle, and we can write exterior angle as a sum of two interior opposite angles, right? So alpha is theta plus phi. है ना? Alpha is the exterior angle for this triangle. Look at the cursor. So alpha is theta plus phi. So we can write alpha minus theta as phi. So this is nothing but RF sine phi. Okay, or we can write this as F into R sine phi. And R sine phi is this ON. We have a particle, and this particle is rotating. No talking, please. This particle is rotating in XY plane because of force F acting on the particle. What will be the direction of torque? Yes. Torque will act on z-axis, perpendicular to the xy plane. Why? Because torque is the vector product of R and F. ठीक है? तो अगर हमारे R और F xy plane में होंगे, तो torque हमारा z-axis में लगेगा. ठीक है? Perpendicular to both R and F. Okay. So if the particle is rotating in xy plane, then torque will act along z-axis. Because torque will act along z-axis, इसका मतलब क्या हुआ कि x component of torque is 0 and y component of torque is also 0. So we have no x and y component of torque. Clear? But the force may rotate the body in 3 dimensions. Implies 3 rectangular components. Now, because we write torque as R cross F, vector R cross vector F is torque. Okay, so we can write torque in terms of Cartesian coordinates. We can write torque as tau x I cap plus, now take the y component, tau y j cap tau z k cap. Now write R, vector R in terms of rectangular components, xi cap plus y j cap plus z k cap cross product. Now we can write for F, x component of force along x-axis, yes, y component of force into j cap fz k cap. Now take the cross product and then we'll compare the unit vectors. Okay, we can write this in determinant form. First write I cap, j cap and k cap. Now we'll write the x component. Sorry, vector for vector R we'll write it's x, y, z. Now we'll write for F, fx, fy, fz. So we'll get I cap in the bracket. We have, this is how we multiply, na? yfz minus zfy. So yfz minus zfy plus j cap. What should I write in the bracket? zfx minus xfz. ये क्या हुआ? क्योंकि अगर आप माइनस जे कैप लिख, यहाँ पे माइनस जे कैप लिखना होता है तभी आप नीचे से ऊपर नेगेटिव लोगे. अब हमने प्लस जे कैप कर दिया तो वो नेगेटिव अंदर चला गया. ठीक है, ये वेक्टर प्रोडक्ट में किया था ना डिटर्मिनेंट फॉर्म. प्लस के कैप in the bracket we'll write xfy minus yfx. Now compare the coefficients, all the unit vectors. Compare this with this. What will you get? Tau x is yfz minus zfy tau y zfx minus xfz tau z. माइंड आपका कहाँ चलता है? tau z is xfy minus yfx. ठीक है? Now enclose this inbox. Rotational analog of force, what are its units? Who knows the answer? Mudit, do you know the answer?
Yes, ma'am. It's force. It's torque.
Yes, it's torque, and the unit of torque is Newton meter. Unit of torque is Newton meter. Second question is, write an expression for torque and which rule is used to find its direction. How do we write the formula for torque? Torque is R cross F, and we can find the direction by right hand rule, right hand screw rule. Okay, we can use the right hand screw rule to find the direction of torque. Next question is, name the physical quantity which is expressed by the moment of force. Yes, answer is torque. Next question is, why is the handle of a screw made white? Mudit, do you know the answer?
No.
See, Why is the handle of screw made wide? A larger perpendicular distance means less force is required to turn the body. ठीक है? See, if we increase the distance, then less force is required to move it because torque is R cross F. ठीक है? On increasing R, even if we apply less force, we can produce the same rotating effect. ठीक है? जैसे अगर हम R को increase करते हैं, if we are increasing R and we are applying force in this direction, ठीक है? So this force produces the rotating effect जो होगा वो अच्छा प्रोड्यूस होगा. तो हमें कम फोर्स अप्लाई करना पड़ेगा बिकॉज हम आर को इंक्रीज करके फोर्स कम अप्लाई कर सकते हैं कि उसको हम रोटेट कर पाए. ठीक है? नेक्स्ट क्वेश्चन. राइट द एक्सप्रेशन फॉर टॉर्क इन कार्टेशियन एंड पोलर कोऑर्डिनेट्स.
Fy minus by Fx, and in polar coordinates Rf sine alpha minus c.
Yes. In Cartesian coordinates, we can write torque as tau as xfy minus yfx. So what is the direction of torque here? Along z-axis. Why along z-axis? Because you can see that both r and f are in xy plane and torque is perpendicular to both. And how do we write in polar coordinates? In polar coordinates, we can write tau as rf sine phi. And what is phi? Phi is the angle between vector r and vector f. Why do we prefer to use a wrench with a long arm? If we increase the length, then
The perpendicular distance will be more, so the torque will be more.
yes, then we need to apply less force to turn a nut or bolt. Next question is to open or close a heavy door. Why force is applied at right angles to the door? Why do we apply force at right angles?
And the force is maximum.
Torque is maximum, bache. Because it produces maximum torque. Next question is, it's not easy to open or close the door by pushing or pulling it at the hinges. Why?
Because the perpendicular distance is 0.
Yes, because R is 0 and torque is minimum at the hinge. Torque and work are both equal to force, time, distance. How do they differ? First you tell me, then I'll explain to you.
Torque is a vector quantity, and a scalar quantity, and work is a
Bolo. Work is a scalar quantity while torque is a vector quantity. How do we write the formula for work done? We write vector F dot vector R. It is the dot product. And here we have, how do we write torque? We write torque as vector R cross vector F. Here we have cross product. Okay. In case of work, suppose we have an object and we are applying force at an angle theta and object displaces by some distance r. Then this force, how do we take this force? We take the component of force in the direction of displacement. यही करते हैं ना? We write fs cos theta or fr cos theta in this case. ठीक है? We take that component of force which is in the direction of displacement. Object is displacing in horizontal direction. So we take the component of force which is in the horizontal direction and that component is f cos theta. Right? But while in case of torque, how do we write? This is R, vector R, and we apply force like this. And it produces rotating effect. this is what we have in torque. Find the torque of a force 5 I cap minus 2 j cap plus 7 k cap about the origin, which acts on a particle whose position vector is this. Please do this question now. So what is vector F? Vector F is 5 I cap minus 2 j cap plus 7 k cap. And vector R is 2 I cap minus j cap plus k cap. How do we find torque? What is the formula? Yashika?
R cross.
Yes, it's R cross F. So torque is,
Ma'am, R cross F.
yes. So it is the vector product of R and F, right? So we can write, we can find the vector product using determinant method. How do we find vector product? In the first row, we write all the unit vectors that we have. In the second row, we write the coefficients of this, x component, y and z component of vector R. It's 2, -1 and +1. Now we'll write for F, it's 5 I cap. So we'll write 5 here below I cap, and -2 will be written below below j cap, and this 7 can be written here under this k cap. Okay, now write I cap, hide this row and this row and this column. So we have these 4 numbers, cross multiply these numbers like this in forward direction. Okay, when we go from bottom to top, we put a negative sign there. So it's -1 into 7 is -7, and here we have 2 negative signs, so we'll write +2. We always write this, for j we write negative, because how do we do it? See, ये आपका 1 1 है and this is your 1 2, है ना? First row and second column, first row and third column. Okay, so this is -1 raised to the power 1 plus 2. This is how we do. We have an odd power here, so we'll put a negative sign. You might have done in maths. So therefore we take j negative. Now hide your first row and second column. Now we have these numbers 2, 5 and +1, 7. Again cross multiply these numbers. Mark the arrows in forward direction. Okay, bottom to top is negative. So 7 2s are 14. Plus minus minus, 5 1s are 5. Similarly, we'll write for k cap. K cap is positive because it is 2 2. Sorry, it is 1 3. First row and third column. So we'll get 4. -1 raised to the power 4 is +1. So therefore k is positive. Yashika, do you know this convention? Do you know how to find the vector product?
Yes, ma'am.
Okay, great. Again, we'll cross multiply these numbers this time. So we have -4, and he'll put a negative sign, minus minus plus, 5 1s are 5. This is how we do. So your answer is -5 I cap. 14 minus 5 is 9. -9 j cap. And this is +1 k cap.
So
देखो इस क्वेश्चन में क्या है? A particle of mass m is released from rest from point P at x is equal to x naught. So we have released a particle of mass m from here. Okay? And this point P is at a distance x naught from origin on the x-axis, and it falls vertically along y-axis. It falls like this, as shown in figure. So what is the magnitude of the torque acting on the particle at time t when it is at the point Q with respect to O. You can see the distance between O and Q is given. It's small r. And because mass of the object, this particle is m. So it is this is the final position of the particle. This was the initial position. Initially particle was at P. Okay. And now after some time, after time t, it reaches this point. This is the final position of the particle. Now, because weight acts in downward direction, right? Because of gravity, so this mg is acting in downward direction. So this is the force that we have. Now you can see that this F and this R, है ना? So we have different directions, right? So this angle is theta. Now just join this component, join this and find the component of R. So what is the component of R along this? This line which we have constructed here. We can write this R in component form. So this component is R cos theta, while this component is R sin theta. Okay? So because we can write a torque is vector R cross vector F. So let's consider only the magnitude first. Okay, and if we consider only the magnitude, then we can write this torque, magnitude of torque as magnitude of R cross F. We'll take only magnitude. We are not considering the directions here. Okay, then we will get RF sin theta. Now what is R sin theta? Write R sin theta in a bracket. R sin theta is nothing but this x naught, right? So x naught is R sin theta. And F is mg. So in place of F, we can write mg. And in place of R sin theta, we can write x naught. So torque is mg x naught. Okay. So this is the magnitude of the torque. Now we can see both R and F, they are in xy plane. And R and F both are in the xy plane. So what would be the direction of torque? Direction of torque is perpendicular to, sorry?
Towards z axis.
Along z axis. Perpendicular to xy plane, right? So we can write torque in vector form as mg x naught k cap.